All right, chemistry class, let's look at chapter 16. And let me just, as I've done in the past, just go over a couple of these terms for you. Temperature, you have to know that temperature is the average kinetic energy of the particles that you are measuring the temperature of. And kinetic energy is measured by 1/2 mv squared. So you should recognize that mass and velocity are involved in kinetic energy, but temperature is the average kinetic energy. So some particles are going to be moving faster than others. If you take a sample of a pure gas, like just oxygen, some of those oxygen particles are going to be moving faster than others, but you're looking at the average of that and finding the average kinetic energy, and that is what we are measuring when we measure temperature. Okay? You should also notice that in this formula for kinetic energy, that it is v squared, 1/2 mv squared. You notice that the velocity there has a larger impact on the overall kinetic energy because that quantity is being squared. You should also notice that if the temperature of two different gases is the same, it means their kinetic energies are the same, but that would mean their masses are not the same, their velocities are not the same. Their kinetic energies are the same, but two different gases don't have the same mass. So that means the lighter one has to be traveling faster to match the kinetic energy of the heavier one. Heat is a form of energy that is transferred from one object to another object. It is always transferred from low temperature to high temperature. Sorry, it is always translated from high temperature to low temperature. Okay, heat always goes from high temperature to low temperature. The specific heat simply means how much energy is needed to raise the temperature of a particular substance, 1 gram of the particular substance by 1 degree Celsius. So specific heat is basically how much energy, joules, how many joules or kilojoules, probably just joules, how many joules do you need to raise the temperature of a gram of that substance by 1 degree Celsius. So it's a joule per gram Celsius. Energy lost or gained. So this is your, remember, I think I wrote this as maybe QSMAT, okay? So here it's, this C is the same thing as the specific heat, M is the mass, and then change in temperature, delta T. But QSMAT basically is how do you find the energy gained or lost. Enthalpy, remember, is just heat at a constant pressure. If the reaction is happening under constant pressure, then this is the amount of heat that is involved, either gained or lost. Endothermic means heat is going into the reaction. Exothermic means heat is going out of the reaction. Gibbs free energy, remember that is using the G symbol. Delta G is equal to delta H, which is your enthalpy, minus the temperature in Kelvin, that has to be in Kelvin, times delta S. Delta S there is your entropy. Entropy, remember, is chaos or randomness. So this delta G is the total amount of free energy or available energy. It just means how much energy is there for the reaction. Remember, if delta G is negative, that means it is spontaneous. That means the reaction will occur on its own. It may take a real long time, may be very fast, doesn't matter. We just know that if delta G is negative, that it is spontaneous. You also should know about enthalpy and entropy, which one is favoring a spontaneous reaction, okay? Enthalpy, exothermic, helps a reaction be spontaneous. And for entropy, more chaos, more randomness helps a reaction be spontaneous. So if you might want to look back at your notes or the interactive reader and look at the different combinations. When delta H is positive, when delta S is positive, when delta H is positive, when delta S is negative, negative and negative and negative and positive, and which one of these under those 4 different conditions is going to produce a spontaneous reaction, which one is not going to be a spontaneous reaction, and which ones of them depend on temperature. Okay, let's look at these right here. Calculate the free energy. So I'm just going to write down the equation really quickly. So calculate the free energy for the decomposition of sodium chlorate. Assume reactants and products are that. And notice you are given right here, you are given the delta H, you're given the delta S, and you're given a temperature. You have to convert that to Kelvin. Remember that basically it is 273, so it is Kelvin plus 273 is going to give you your Celsius. Okay? Oops, sorry, my fault. Celsius plus 273. Okay? So, Kelvin is 273 plus Celsius, and that's going to give you the value that you're going to have right here. Okay? So make sure you always convert it to Kelvin. And then they're giving you, right there, they're giving you the delta H, they're giving you the delta S, plug in all of your values there, and you should be able to find delta G. If delta G is negative, it is a spontaneous reaction. Also, make sure you look carefully at these units. Make sure that they're both kilograms, or sorry, kilojoules, or both joules, but they have to be the same, otherwise you have to convert one to the other. Otherwise, so just be aware of that. Don't miss the units, okay? Let's see here. Calculate free energy. Again, same idea. Convert this to Kelvin. You are given delta H, you're given delta S. Use the equation I just provided you in order to find that. This one is very similar. Calculate free energy. Change that to Kelvin. Use your delta H, use your delta S. Okay? This time it says calculate the change in entropy. So the same equation, but this time you're given the delta G, you're given the delta H, and you need to change that to Kelvin and solve for delta S. Okay? So check your answers here and let me know if you've got questions on those. Okay? So that's chapter 16. It's all about free energy. It's all about the energy that is lost or gained. It's all about spontaneous reactions. Again, you got to let me know if you got questions. Look back at your interactive readers. Look back at the practice quizzes in Schoology. There's lots of resources for you to study and therefore do well on the final exam.